It's our project where we basically are comparing two denoising implementations on the TSU versus a normal GPU.
Right, and our motivation was that now that we have thermal, we can actually simulate what the TSU would look like, and show a functional implementation of the denoising process on a video, and then we do the same implementation on a GPU, and we measure the power consumption every 5 milliseconds, and then we get an average for the joules consumed for denoising a video. Here are our key results. On the top, you can see the conventional H200 running a classical algorithm for denoising, but it is GPU-based, running on CUDA. So this is the best case situation. And then on the simulated TSU, we implemented the same thing, albeit it might be a little bit lower fidelity, but we have a 179,000x difference. And you can see that they're pretty comparable, and you can see how it can easily scale up if we just added more dimensions, because right now we were able to just get it running as just a quick demo, just to see how comparable denoised images are going to have an actual difference in energy consumption.
Cool. Yeah, so in terms of just a high-level overview of the problem, we apply random salt and pepper noise to these grayscale images because we found that this just works best as an initial condition for this type of thing. And yeah, that's pretty much all for this.
Yeah, so we found a way for the TSU to denoise an image, and once we got that, then we compared it against real hardware on a CUDA-based GPU to prove the energy consumption difference. Now, these are results from the TSU itself.
Yeah, and these are just for still images that we use for prototyping. So you can see here, these are just some denoising results on some classic.
Using thermal.
Yeah.
Yep.
Cool. And then, yeah, all those images are on our repository.
Yep. And then the baseline GPU based denoiser, it uses the NVIDIA H200, and then we were able to actually utilize the CUDA-accelerator. And then here are some of the details on the measured total energy. It used 8 joules to process this video, which is, again, 179,000 times more energy than what is anticipated based on the paper of the energy consumption of the TSU kernel.
Yep, and then I just basically estimated pessimistically that every single warm-up stage, all the samples we take in every step per sample would contribute to the energy. And then I just used the energy per sample, the joules per sample that were presented in Extropic's paper for the hardware. And next, this is it?
Yep.
Okay, cool. And then we're just going to do the demo real quick, where this is just it running and generating the GIF. And it should take a couple seconds because it needs to JIT the kernels first. Okay, so this is the final a video after it's been denoised by the TSU. Boom.